loud. All right. So when we're solving quadratic equations, we have several different methods. We've already learned to solve by taking the square root of both sides. Okay, so previously, if we had a problem like 2x squared equals 50, we would divide both sides by 2 and we would get x squared equals 25. And then we would take the square root of both sides and we would get x equals plus or minus 5. Right? And if this was, maybe this would be negative and this would be negative, and then we'd have a 5i here, because when we take the square root of a negative, we get an I. Okay? And we did all kinds of these and more complicated ones and so forth. But this method only works if we have a quantity squared or an x squared term without a plain x to go along with it. Okay, so we can't always rely on that strategy for solving. And so we're going to learn some other strategies as well. And so today, well, we did factoring yesterday, but not every expression can be factored either. Okay, so like I gave you expression like x plus 25 on the lesson for factoring. And I said, this can't be factored. This is prime. So I cannot solve this by factoring. So I'd have to use another method. Well, I could subtract and square root in the same manner as I did up here, but what if it has 3 terms and it can't be factored? Okay, so that's where completing the square comes in. So the first thing we want to do is kind of review perfect square trinomials, and that's what all of these are. So if I have a perfect square leading coefficient, or I'm sorry, a perfect square first term, so this is x times x, and I have a perfect square last term, 2 times 2, and if these two add up to the middle, so 2x and 2x add up to 4x, I can't make a tiny error there. Whatever. Anyway, so if that pattern holds true, then we can factor these with a shortcut, okay? And the shortcut is, will we do those down at the bottom? No. So if I want to factor these, I can factor it to x plus 2 quantity squared. Okay, it does. So the next one, that's x times x, that's 4 times 4. If I make them both negative, negative 4 times negative 4 gives me positive 16 and negative 8. So this would be x minus 4 quantity squared. Okay, and then this last one, same thing, x times x, 10 times 10. They need to both be negative to add up to negative 20. So that's going to be x minus 10 quantity squared. So if you look here, you've got the 10 squared, that represents the 100. Okay. And then if I wrote this out, x minus 10 times x minus 10, and I did the outer term and the inner term, I'd have negative 10 and another negative 10, which gives me negative 20. Okay. So I'm just using that perfect square trinomial shortcut to factor. And I know I'm going to get the same factor twice because it's a perfect square trinomial. Does anybody have questions about that? So we used the shortcut and we already talked about this pattern. So the pattern is that they all have the same 2 binomial factors. And the first and last terms are perfect squares, okay? So I don't know, we've already learned this lesson. They're perfect square trinomials. So first and last term are perfect squares. They have, whoops, they have the same 2 binomial factors. How about, and let's simplify that and say identical binomial factors. That's less writing. Okay, so perfect square trinomials, we wrote these patterns down in our notes when we did this lesson earlier. So the pattern is that you have a perfect square first term, you have double the A and B. So like here you had A, if this was X squared, then it's X times X. X is your A. And then 100 is 10 times 10. So 10 is your B. So you have that A times B, which is negative 10 times X, twice. And that's where the 2AB comes from, okay? And then the last term is your other perfect square. And this pattern could hold true if there's a plus here or if there's a minus here. I have a question to think about. And if you think you know, some of you are talented mathematicians, if you think you know, feel free to answer. Why do you think this last term is positive on both of these? Why do we think we have to have a plus for the B squared? Anybody? Garrett, you have a very thoughtful look on your face. Okay, well, I'm gonna say that it's because you're taking a number and squaring it. Anytime you square a number, it turns out positive. Okay, so multiplying a negative times a negative or a positive times a positive, still going to give you a positive result in the end. So that's why the last term is always positive, but the sign that's inside your two factors, the negative or the positive, is dependent on the sign in front of your linear term because we want them to add up to the correct signs. Okay, so moving on to example 1, first we're going to find the value of C that makes the expression a perfect square trinomial. So now I have to work in reverse and figure out what perfect square at the end of the expression would create a perfect square trinomial given the two parts that I already have. Okay, so let me see if I can move this up just a hair. Okay, so I've got x squared, so I know that part is the x times x situation. And I know I'm going to have something here that has to be a perfect square. So what times it, oh my goodness, what times itself can give me a number here that's a perfect square and also add up to 16? How could I figure that out? Well, I have to have two matching numbers that add up to 16. What could they be?
4 and 4.
4 plus 4 would be 8. So what two matching numbers can add up to
8 plus 8.
11? 8 and 8. So we need 8 and 8 and 8. So I could have, that would give me 8x and another 8x. That's a beautiful 8 that I wrote right there. My class pads really doesn't want to cooperate. So 8 and 8 would give me 16. So 8 times 8 is what this number will be. So the C value here will be 64. So what do you think about the next one? What's my C value gonna be? And how could I get to it without having to draw this? My last semester class called this a castle. I guess because the peaks at the both sides. Without having to draw this castle, is there a shortcut that I could take to find C? Like whatever you, go ahead, Maddie.
Divide negative 12.
We're going to divide the middle term by 2 and then square it. Very good. Because I know it's going to be half for each, and then those are going to get multiplied together over here. So if I take half of negative 12, that's negative 6. And if I square that, that gives me 36. Very good. And so if I take half of 6, and again, maybe I do need to write something down. So this would be 3x and 3x. 3 times 3 is 9. Okay? So you're going to basically take half of B and square it. And that'll give you your C value. The constant. Okay? And I remember why I didn't want to use these letters. This B is not the same as this B up here. Okay? I should have used totally different. This is just common notation in mathematics for the patterns for perfect square trinomials, and it just happens, I don't know why they use A, B, and C, but this B and this C are referring to like AX squared plus BX plus C in your perfect square trinomial. Okay, so you take half of B and square it to get C to make a perfect square trinomial. All right, so down below here, we're gonna fill in those perfect squares that we found. So 64 goes here. These are the same problems, okay? 36 and 9. And now we are going to write them in factored form as a binomial squared. So that means we're gonna write that same identical factor squared for each of these expressions. All righty, so I want to rewrite this as a binomial squared. I know this sign is positive, so I know it has to be a plus. What number is going to go inside of here? What number adds up to 16 and multiplies to 64?
8.
8.
8, very good. All right, so it's this number that we used up here for the half of 16. All right, so here this one's going to have an x and a quantity squared, and it's going to have a minus because of this. So the two numbers that will multiply to 36 and add up to -12, -6. It's that half of B number, okay? And then over here, x, half of 6 is 3. 3 plus 3 is 6, and 3 times 3 is 9. All right? So these are sort of things that you might have already known, but not really thought too much about. The more that we practice and process with this pattern, the better we will be at completing the square. And again, since I love completing the square, I want you to be awesome at it. All right. So it says, recall we can solve some equations involving perfect square trinomials using the square root property. This is something that we already sort of learned. This here is a perfect square trinomial because half of 14 is 7 and 7 squared is 49. So this fits the perfect square trinomial pattern. So I can factor this as x plus 7 quantity squared equals 64, which then I can square root both sides to solve. And that gives me x plus 7 equals plus or minus 8. Subtract 7. So I get -7 plus or minus 8. That's going to give me 2 answers. So -7 plus 8 is +1. And -7 minus 8 is -15. So this is something that we have already practiced. Although we didn't factor it first, we could factor this, square root it, and solve that way. All right, so what we're gonna do today is we're gonna try to force problems that can't be factored using that pattern to become those types of problems to make them easier to solve. And that's basically the whole concept behind completing the square. All right, so it says, what do we do when the left side is not a perfect square trinomial? We're gonna turn it into a perfect square trinomial so we can do that same process again, okay? So here's what we want to do. And I'll walk through the steps. This is gonna seem like a lot. Hopefully you remember it from Algebra 1, but it's gonna seem like a lot the first time we go through it and we're doing all of these steps and talking about them, but then it can become a really fast process. All right, so we're gonna add or subtract the constant. That's what goes in here. Add or subtract the constant to the other side of the equation. So that means we wanna add this 12 over to here. Now, I'm gonna leave a space where this 12 was, I'm gonna leave an empty space here. I usually literally draw a box or a square because I'm gonna complete the square by filling in this square. All right, so on this side I have x squared plus 4x plus whatever perfect square I'm gonna put in there to create a perfect square trinomial. It's always gonna be a plus because any number squared will become positive result. All right, and on this side, I'm gonna have 12. And if I add some random number to the left side of the equation, I have to add that same thing to the right side. All right, So that's step one, get the constant out of the way so that you can create a perfect square trinomial. So this is that C value that we found up above in example 1. All right, so now it says add b divided by 2 squared to both sides of the equation, both. All right, so we're gonna take half of b, so half of 4 is 2, and we're gonna square it. Maybe I even, no, I'm not gonna do that. So half of 4 is 2, 2 squared is 4. So I'm gonna add that to both sides of the equation. All righty. Then next, I'm going to factor and write it as a binomial squared. So I'm gonna factor this side. So what I'm doing is making 2 factors, but they're the same factor, just like we did up above. And that's gonna be x plus 2 quantity squared. And then on the other side, I'm gonna combine like terms, which it's always gonna be numbers. So 16 on this side. Anybody have any questions so far? Okay, all right. Then we're gonna take the square root of both sides, because the square power and the square root are inverse operations. So we're gonna solve it. Basically, we're just solving like I did on this little example up above with the square root property. So I have x plus 2 equals plus or minus square root of 16, which is 4. Okay, so we're almost finished. Don't forget, what do you think it's telling you to not forget? Plus or minus. Don't forget the plus or minus, which is, again, a common error. We can't get 2 answers if we don't put plus or minus there. All right, and then it says isolate x, which means just solve it for x. So subtract 2, you get x equals -2 plus or minus 4. And then add and subtract to get your 2 results. Okay, so I'm gonna do the subtraction first so that I can write the smaller number first in my solution set. -2 minus 4 is -6, and -2 plus 4 is +2. Then you can check your answer. You have multiple options for checking. One option is to substitute the answers into your original equation, one at a time, not both at the same time, obviously. So first you would substitute -6 everywhere there's an x and see if it turns out to equal 0. And then you could do the same thing with a 2, plug it in, make sure it works. Your other option, use your graphing calculator or your table function in your calculator and look for the zeros in there, okay? You can do those options when the answers turn out to be integers, meaning positive and negative numbers with denominators of 1, not fractions or decimals, and obviously not imaginary. But you can always plug them back in and make sure they're right. And when you're taking a test, you know, of course, I would advise you, if you're solving, to plug your answers in when you're finished, because then you know if you got them all right before you even complete your test. Any questions? All righty. So we're gonna go on to the next page and practice some, and I'm gonna show you, it's not a shortcut, it's like, well, it's a condensing of the process to help you remember how to do it, okay? So here we go. And we don't have a whole bunch of examples. I have some for you to try on your own, just to walk through the process and see if you understand, and some strange outcomes that could occur. I'm disappointed with myself because I wish that I had chosen a problem that has a different number in the middle besides 4, since we already did 4. But I had already completed this packet and submitted it to y'all to be printed when I realized that. So here we go. Step 1, get rid of this constant. So we're going to subtract 11 to the other side of the equation. And so that gives me x squared plus 4x plus some perfect square of my choosing. And then -11 plus 2 is -9. And I'm going to add the same perfect square to the other side. All right, now here's where my trick comes in. And the trick is not really a trick. It's, can I write? That's the trick. Maybe I'll write it over here where I have more space. It's half it, drop it, square it, add it. All right, so I'm going to do a bunch of steps all at the same time using this half it, drop it, square it, add it process. So if you're working along because you know what you're doing, if you'll just stop and watch for a second, this will allow you to combine steps and get it right more consistently. Okay, so here's what we're going to do. We're going to look at the 4. We're going to take half of it. Half of 4 is 2. While the 2 is in your head, go ahead and drop it into the parentheses. Okay, so half it, drop it into the parentheses, square it, and then square that number and add it. So 2 squared is 4. Okay, so you're combining the steps of adding the correct number to both sides and getting it into factored form. A lot of times students forget the square part, then they don't take the square root right, and then the rest of the process gets messed up. And then the other thing is a lot of students get this side correct because they know that where the factor came from, but they forget to add the number to the other side. So they'll proceed with a -9 over here and miss the whole problem after that, okay? We will use completing the square later when we're doing some graphing and conic sections and parabolas, I think. So this is a process that you'll have to be able to use again. I mean, normally you would in Algebra 2. All right, so then I get -5 over here when I combine. So I'm ready to square root. And then I get x plus 2 equals plus or minus I radical 5. Bringing out an I because of the negative. Hopefully you haven't forgotten about that. It's been a while. And then I'm going to subtract 2 over to here. And I get x equals -2 plus or minus I radical 5. Since our solutions are imaginary, that means if I went to graph this in Desmos or my graphing calculator or look at the table to find the answers, they would not be there. It would not cross the x-axis. The whole thing would be like above somewhere. I don't know exactly like what this particular one looks like without taking a minute to think about it, but it would not have any real zeros on the x-axis. Okay? And again, you could check your answer by plugging it back in, although it's quite tedious to. So if you were writing this as 2 separate solutions, it would be -2 minus I radical 5 and -2 plus I radical 5. So let's just remind you of that. Okay? Any questions about that? All right. Last example, and then I'm going to let you guys try. You can see that the leading coefficient here is 2, and we haven't done any that have a leading coefficient other than 1 yet. So ultimately, this process is easier if that leading coefficient is 1, and we have chosen this semester because you're learning remotely and doing these with a leading coefficient and also with a number in the middle that's not even is a challenge. And if you had a choice, then you probably wouldn't choose to complete the square. Then we're not going to force you guys to do those. And so we've given you ones that either they can all divide by a common factor or it's always going to have an even number in the middle. So you're welcome. So this, you have a GCF of 2. We're going to divide every term by 2. You could go ahead and add the 10 first and then divide by 2. It's up to you, but I'm just going to divide everything by 2. Because I have a 2 in the front and I want to get rid of it. And it's not a perfect square, so I can't make a perfect square trinomial with a 2 on the front. So now I have x squared minus 2x minus 5 equals 10. So I need to move this 5 out of the way, so I'm going to add it to the other side. And I have x squared minus 2x plus something equals 15 plus something. Now I'm ready to complete the square. So I'm going to half it, drop it, square it, and add it. So half of -2 is -1. drop it into the parentheses, square it, and 1 squared is 1, add it to both sides. So on the right-hand side, I get 16. Now I'm gonna square root, and I get x minus 1 equals plus or minus 4, and then add 1, and I get x equals 1 plus or minus 4. So my two solutions, 1 minus 4 is negative 3, and 1 plus 4 is 5. Now, if you get nice numbers like this, then that means it could have been factored from the beginning. And you could have chosen to just make it equal to 0 and factor. If you have a choice, you can do whatever you want. If you don't have a choice and it says completing the square, then there you go. Do y'all remember this from Algebra 1? Does this seem familiar? I hope, maybe. I got a lot of black squares on my screen. All right, everybody try number 1 right now on your own paper. And hey, we got a number besides 4, so that's good. I'm gonna give you a minute to try it and let's see how you do. When you're finished with this problem, share your screen with me so that I know you're finished and that you're actually working on something. Oh, no, not share the screen, I'm sorry. I mean, just turn on your video. Cool. All right. All right, y'all, here we go. So I'm gonna start by doing what? Caitlin, can you tell me the first step?
I subtracted 78.
Perfect, you subtracted 78. So we're gonna move 78 to the other side of the equation. And then what did you write down under that?
X squared plus 20x plus the square and then equals 75.
Possibly negative 75?
And then plus square.
All right, thank you very much. Okay, Bailey, do you know what to do next?
I don't know if I did this part right.
Well, let's see.
Well, I don't really know. You divide 20 by 2.
Yes,
Did you say you square it?
yes. So
Yeah.
when you divide 20 by 2, that's the half it part, right? You took half.
Yeah.
Okay, where do we drop it? What's the drop it part mean? Do you remember?
No.
No. Okay, so after you half it, you're going to drop it into the parentheses so that it starts to come into factored form. Okay, so you take half of this number, which you did, drop it into the parentheses, and then just like you said, you square it. So I'm going to actually square my parentheses, which gets my trinomial into factored form. And I'm going to square the 10, which puts 100 as my perfect square on both sides. Whoops.
I did that.
Okay, cool. All right. Haven, what should I do now?
So now you have 100. So you take, well, you do negative 75 plus 100, which is
Very good.
25.
Excellent. Okay, I'll let you stop there. I'll choose another victim. Sailor, what now?
You square root it.
Perfect. I'm going to get a different color just to show that this is a different step. So when I square root it, what happens, John? What do I get on the left? I thought I saw the top of his head there. Now he's gone. I see this. John, what happens when I square root both sides?
The 25 turns into a 5.
Okay. And what else goes with the 5?
I couldn't figure out what the other side does.
This side over here?
Yes.
Okay, so the square power and the square root are going to eliminate each other, and it's just going to basically dump the stuff out of the parentheses like this. Okay, and you are correct that this side is gonna be a 5. Sarah, what's he missing from this side? That's super important. We wrote it in the blank. Don't forget.
Plus or minus.
Very good. Don't forget plus or minus. That's how we get our 2 solutions. All right, we're almost finished. Jeremy, are you there? He was having technical difficulties earlier. Jeremy Warden, my only son, are you there?
Yeah, I'm here.
Mm. Can you answer a question?
Yeah.
Speak loudly, loud and proud. What do we do next?
After this, you just do inverse and you bring your 10 to the other side and make it plus or minus 5 minus 10.
How about let's put,
equals-
I like the minus 10 part. I want to put it in front of the plus
Okay.
minus. So it's like, I know I'm going to be doing negative 10 plus 5 and negative 10 minus 5 because the order matters when you subtract. So that's an easy mistake to make if you put the 10 at the back. Thank you, Jeremy. All right, so to get my 2 answers, I'm going to do the addition and subtraction. And just so that I can be the best mathematician I can be and put my smaller answer first, I'm going to do the subtraction first, but I wouldn't count it wrong if you didn't do it that way. So negative 10 minus 5 is negative 15. And negative 10 plus 5 is negative 5. And again, we got 2 nice answers here. It doesn't always work out that way. When I think that the process of completing the square is the most handy is when you have something that couldn't be factored and it couldn't be, you couldn't take the square root of it. So your only choices then are either completing the square or quadratic formula. And if I have the choice between those 2, I'm fast at completing the square and I don't like to have to get my calculator and type things in it. So I would choose completing the square. Quadratic formula will work for every problem. Completing the square is only really mostly handy if that middle number is even because you have to divide it by 2, okay? All right, let me stop my recording. We don't have to record the rest of this. Give me the menu. Do you want to stop? Yes.